Hey class, so we will be continuing on with the Kistefos Museum by B.R. Kingles. Today we'll be going over work sets, which is essentially layers in Revit. We'll also be developing the exterior skin a little bit, as well as some structural elements, um, and then we'll see how far that goes. All right. So the first thing I wanted to point out, I got a couple questions about levels in 3 dimensions. I think it came out in Revit 2020. So if you're using Revit 2018 or potentially 2019, you're not going to be able to see these, but that's okay. I'm going to turn them off just so there isn't any more confusion about that. All right. And then some other people were saying that they couldn't see the reference lines when they went into a left or a front view. That also is part of the 2020 update. If you can't see those reference lines or anything that you've created to dimension from, that's when you need to start using the other elevations. So east elevation, or you can take a section cut through the building if there's a specific reference plane that you want to utilize. But hey, so those were some of the issues that were brought up. There's always a workaround, so just keep trying different things until you find one that works for you. So work sets. Work sets are essentially layers that you would find in Rhino. They allow different elements to be associated with different work sets, and that you can turn on and off of them based on what you want to edit. Typically, you'll have like floors, skin, core of the building, site will be on a work set, etc. And to do that, to create these work sets, up at the top under Collaborate, click Work Sets, and then you're about to enable it. So this is going to ask you where you want to move the levels and grids, and then all the rest of the elements. So shared levels and grids is fine for the levels and grids. The remaining elements, I actually like to do building core, so that I don't have to worry about anything. I don't like leaving things on a random work set. Alright. Okay, so then it's going to open up this window. This is your work set manager. To create a new work set, new, I'm going to create one for site, and then one for skin, building, skin, and then one for structure. All right, and then there's a couple different things. So you can actually make these not editable, and so what this does is if you're working with multiple people, it'll actually ask you, it'll make it so that you have to make it editable, and it will notify the person, the owner of the element, that you're doing that. So let's say I'm working with one of my coworkers, let's say his name's Pete. If Pete wants to work on the building core and I've turned this as not editable, then he has to essentially alert me to when he is working on this work set, and it gives a little bit of a better workflow to make sure that people aren't working on different things. In our office at Little, we don't typically do that, just because multiple people are going to be working on one work set at a time, especially when you have stuff as general as core. Some people may be working on the bathrooms, other people may be working on the interiors. So we don't typically do that. What we will do though is either close certain work sets. For example, MEP models are very heavy. They're very detail oriented, And so sometimes we'll like to close those just so that they're out of the project and it lightens the load on the computer's memory. And then the last one and the most important is visible in all views. So let's say site. We only want the site to turn on in certain views, but not in the majority of drawings. So we'll turn that off, and you'll see that now, instead of the site being on in every single view, you have to go in, if you want to see that in a certain view, you have to go into the visibility graphics and turn it on. All right. So let's press OK. No, not for right now. And then to assign elements to different work sets, you want to highlight the elements, and then underneath the Properties tab, you have a work set, and you can just do the drop down, select the one that you want it to be on. And since we did make site as not visible in every view, it gets turned off. To turn it back on, you have to go into your visibility graphics manager, and then at the far right at the top is work sets, and then it automatically goes to its setting that's in your work set manager, and you can just go to show and it turns back on. I'm going to leave it off for right now, and then we'll assign the rest of these as we go. So what I like to do, especially when you have building already kind of constructed, is you just go in and highlight everything and then filter out exactly what you want. I don't know if I've covered this yet, but curtain panels, systems, and curtain panels and grids and mullions, they're all part of a wall, and they're going to share the work set of the wall that they are associated with. So if you're just turning things to a different work set, you can turn off panels and grids. Keep curtain systems on, but you can turn those off. So I'm gonna select all of the walls and the curtain systems and press OK, and then I'm gonna turn those from building core to building skin, and I believe that should be it. Our floors we want as our building core. At a later date we could even build a building floor when we start to actually integrate different walls, interior walls and interior elements. So let's see. So let us first, what do I want to do next? So I'll create the skin for this building. So we did a quick just associate wall to face, and we have a basic wall. But as you know, I think I have it on here. Oops. Sorry. So if we go to there we go. So if we go to an exterior view, we can see that this skin is faceted, it's panelized, and to do that, we'll actually go in, and instead of having a smooth exterior skin that's from a true wall that's associated to a face, we'll go in and actually create a divided surface in the mask, and use that as our basis to create these facets. Now, the one thing to remember is in the interior of the building, the wall is smooth. So what we're going to do is essentially have two wall systems for the inside and for the exterior. So we're going to leave the basic wall in place for right now. What we're going to do is go in and leave the internal structure that we created in place, but we're going to delete the metal panel exterior. So we're going to essentially be creating the interior part with all the gypsum, and that's going to remain smooth to the face of the mask, and the exterior will be the faceted metal panel. So press OK. All right. And then the one thing we also need to do is change it from our finished face to interior to finished face exterior, so that our interior side is facing in, and that is on our finished face is aligned with the exterior, so that when we build the metal panel, it's going to start from the outer face and go out, and our interior wall is going to start from the outer face and go in. Let's change this. Do that for the one other wall. Okay. All right. So to create the faceted exterior panel, what we got to do is edit the mask and create a divided surface within the mask. And your mask may be hidden, may be turned off in the visibility graphic. So if you want to go in and turn that on, and then you can either tab through, or you can just select and filter out the mask. And let's go edit in place. And then I am going to isolate this element so that that's all I can see. And so we know that this face that turns up and turns to the ceiling, that is going to be our glass. So we're going to leave that alone for right now. What we're going to do is tab over and grab one of these walls that we know is the metal panel. We're going to go up and divide surface like we've done before. And then we're going to go down and select a rectangle pattern. And what we need to do is, of course I know it. And like we saw in the picture, these are all vertical panels. And so what we'll do is create all vertical grids. So we'll want to go in and keep it a fixed number, but change one of these to just 1, which is the wrong one. So let's change this one to 100 and this one to 1. All right, and let's see what 200 looks like. Ooh, too much. 150. All right. Let's do 160. Okay, that looks pretty good. Now you could try and do a fixed distance of like 1 foot, but I don't know. For some reason, it doesn't like doing that. Let's try 1.5. Oh, that worked. Of course, the one sucky thing is you get these leftover ends. Because this is such a complex surface, it probably isn't a even number. So let's just do a fixed number. And 175. All right. Of course, if your model is getting pretty heavy, if your computer cannot take that many divisions, by all means, reduce it, get it to where it's working with your computer and that you can still pan around and do everything that you need to do. By no means am I going to penalize you if you don't have 175 divisions. Just get it so that you're doing the same type of modeling, same geometry. So let's do the one other wall, divide surface, rectangle, 75, and 1. All right. So the one sucky thing about Revit is when you do these equal divisions, they don't line up. And the reason they don't line up is because it is dividing the equidistant it's dividing the center line of the surface. And so each of these surfaces, because it's torquing and twisting at such different rates, the center lines of each don't line up exactly. That's okay for what we're going to be doing. Of course, in real life, they would actually align them. But for right now, it'll have to do. So what we'll want to do is, so we have a rectangle. We've been using the rectangle grid. We need to actually create a surface panel for this. It's going to be pretty simple. So let's finish the mask for right now. Let's go File, New, Family, and go to our current panel, Pattern Based. Open that up. And then it's already on our rectangle grid, so we don't have to change that for right now. And all we need to do, since it's a pretty clean profile, there's not a lot of variation or anything like that. There are some reveals, and we could integrate those. But for right now, we will just use the outside perimeter as our starting point for our forms, and just do a quick create form. Make sure it is the geometry with thickness, and then let's add a thickness parameter. Now this one is going to be type. We want every single panel to have the same thickness. So let's keep that as a type parameter. You can go in and change that to like, I don't know, let's just change it to a foot for right now. And then the one other parameter we're going to give this is a material parameter. So if we select the geometry, it'll populate a material parameter under properties. Go in to the little family parameter button, and then type in material. And again, we want these all to be the same material, so we'll keep it as type. Press OK, and then we'll save this as Kistefos. Save. Then we'll load in to the project. And then we can go back into the mass and change this from our rectangle to our Kistefos metal panel. Give it a second. Okay, and then it's going to have, looks like there's something. Let's make sure. Huh. That's weird. I wonder why it did it. It's weird. You would think that it wouldn't create a panel for one of the twisting ones. Huh, that's weird. Well, we'll leave it for right now. I didn't run into this when I was doing the test. Might be because we have so many divisions. If we continue to run into that, we'll play around with the division count. But for the rest of the panels, change it to, or rest of the walls, change it to the panels. Weird. That one's fine. Real quick, I'm just going to try to reduce this division. See if that helps at all. If not, we'll just keep it and then. No, it does, of course. Alright, let's see how high we can get before it runs into an issue. Uh, 150 seems to work, so I'll just change these all to 150. Alright, cool. So now we have panels. Now, of course, these are, they don't resolve the corners. And so what we can do, let's try something. Alright, so let's go in. First, let's finish the mask. Let's go in, edit family. Let's try and extend this out. Alright, we'll leave it for right now. Now, what you could do really easily is to solve this is basically create a second mask. Actually, that's what we'll do. So what we'll do. So what we're gonna do, we're gonna create a second mask, and then we're going to go in and make the second mask one for the sides, so that this side panel comes up the foot on either side to capture each the top and bottom. So if we copy, so Control C or up at the top, copy to clipboard, and then paste, same place. Give it a second. Alright, go in, edit in place, and we're going to delete the top and bottom for these panels, and we're going to go in and edit the profile. Let's isolate this element so that we have a little bit clearer of a view. So what to do? So when we're going in and manipulating the mask, the easiest and the cleanest way to edit the mask is to edit the profile of the mask. So it basically goes in and edits the control curves that generated the mask. So that'll be our 8 different profiles, or 8 profiles. So we'll go in and we'll increase the height, the top and bottom, by 1 foot. So we'll have our offset 1 foot, uncheck copy, so it keeps the same line. And we'll just go in and do this. And then we're just going to do that for every single profile. And to speed this up, we'll probably want to disassociate this divide surface, just so it's not constantly updating. So we'll go in, just delete that for right now, and then go back in. And there's 2 ways that you can do the edit profile. You can either click one of the profile lines that's on the mask and just hit edit profile. That'll open up the profile that is associated to. or you can highlight the whole thing, hit edit profile, and then go in and click one of the profile lines to bring up that editor. And of course, this is not the most riveting, so you can feel free to fast forward through this in the video. I apologize if there's some background noise. That is the 3D printer. We are 3D printing some masks. Oops, didn't actually edit the profile. Did it again. Alright, so now we've increased the height in the by a foot on either direction. We can go back in and associate the metal panel to the side. So go in, change this from no pattern to the Kistefos metal panel. Okay. Alright, and then we'll finish the mask and turn off our isolate. So reset temporary hide. Alright. Now we have. Oh, I was wondering what that line was, and that is because in our original mask we still have. Ooh, and it's gonna be fun because now there are two masses underneath. Alright, let's go in and hide this one. Now what I did, I hit HH, which is my shortcut for hide element, temporary hide element. It's not there. There we go. So I'm editing the original mask that had the weird corner. I'm going in and deleting the side panel. So now that is empty. Finish the mask, reset the profile, and now a nice clean. We have a nice clean corner with the metal panel on the side going up and capturing the one at the top. Now I want to do the same thing with the bottom. Okay. Anyway. Oh, that's why. Haha. Alright. I'm definitely going to have to go in. So I increased. I was wondering why this corner is so odd. And the reason why is because I increased the top and the bottom by 1 foot along the entire thing. However, the the side that I wanted to increase by a foot changes, obviously, from one side to the other. So I'm increasing the top and the bottom on this side, but the top and bottom are actually the right and left on the other side of the mask. So I am going to go in and fix that. I'm essentially going to decrease the top and bottom profiles by 1 foot and increase the right and left sides by 1 foot. That should fix our corner problem. I apologize. For that mistake. Feel free to fast forward through this. Alright, last profile. Alright, we can finish the mask. And one thing that we can do, since we are kind of copying the mask and using it as just a base, we can go in, edit the mask, go in and select the mask, and then actually go in and uncheck the visibility. So you're still going to be able to see it when you're editing the mask, but when you finish the mask, it gets turned off and you're just left with the geometry that you created inside the conceptual mask editor. Now the other thing that you can do is go in, next to the visible checkbox is a parameter tab, and you can actually create a yes/no visible parameter. So it's a yes/no type of parameter, so it's only going to ask yes or no. I think it's actually just a checkbox. And since the conceptual mask isn't really a family, it's more of a one-time piece of geometry, I always create any parameters I create in the conceptual mask environment as an instance parameter, so it shows up when you select it. So if you hit OK, and then you hit Finish Mask, so it's going to default to not visible, but if you select the geometry under here, at the bottom of the properties, there's that visible parameter we created, and if you toggle it on, it then turns on the mask so you can see it. Alright, and we're going to do that for the remainder of our the geometry that we create. Alright, so it's a little bit nicer. Still not perfect by any means, but it's a much cleaner corner than what it was. And it resolves itself pretty nicely at the bottoms here, which is what we were going after. Alright, so the other thing that we want to do, so we created the metal panel. Now we want to create a custom panel for the glass. Now last time we just created a curtain system, which is fine, but it gives us, especially on our curved radius, it gives us this horrible division in the middle, and we want those to be perfectly straight across the entire face. And so to do that, give me a second. Sorry about that. So where were we? I believe. Remember to save your project. Something to bring up. So when you turn on work sets, it's going to make you create or turn your file into a central model. Not a huge deal, doesn't have a huge effect, but it will ask you to sync instead of save. I think I covered this before. So central files are excuse me. Central files are Revit models that are able to be worked on by multiple people at one time. And what happens is you essentially create one central project file, and then when people go to work on it, what they do is create what's called a local file. And a local file is essentially a separate model that lives on like your respective computers, and you work on that individually on your own time, and then you synchronize that model up back to the central model. And what that does is it keeps people from working on the same element and making changes to it. Say somebody who's working with me tries to change this mullion to a different one, and I've already changed this mullion. If I haven't synced back to the central model since then, it's not going to allow them to change that element until I do. Not a huge deal for you guys right now, but since we did create work sets, we're going to have to synchronize back to the central file. So instead of saving, right next to it, it's called synchronize, and that's essentially how you save back to the central file. So not only do you save, but you also synchronize. And if you do synchronize down here, it's going to have a little checkbox next to save file. Just make sure that one's checked every time. All right. Anyway, so we were going to change this class. Yeah, so we have this central division down from this curtain system. So what we're going to do is delete this curtain system and create a new divide surface along these faces. So if we go in and edit the mask, let's make sure. Okay. So let's see. So let's go in and divide surface, and let's just keep this simple for right now. Let's go in, change it to a rectangle, and then we're going to try and mimic the same exact vertical glass panels that we did last time. One. Alright, and what we can do with this, since generally a good rule of thumb is to have 5 foot wide glass panels, we'll do maximum spacing, and then do 5. Actually, you know what? Let's just see what 5 foot looks like. I've been using the reference imagery for a lot of this. Those are pretty good panels. So actually, let's create 6 foot panels. The reason I'm doing this is because, a typical door is 3 foot wide, and so a double door is 6 feet wide. Now, it typically is like 6'2" to 6'4" between center lines, just to account for the mullion and the frame. But we'll just do a flat 6 foot for right now. So we're gonna keep that. It is. And then what we'll do is we'll create a new family. So let's go File, New, Family, Curtain Panel, Pattern Based. And what we'll do is we'll essentially create a curtain wall system from this. So first, we'll create the glass panel. So we'll just create a basic form. Do the thickness parameter, glass thickness type, and then go in and do glass is typically 1 inch thick. Do the same thing with our material. Oops. Add a material parameter, glass. Okay. And then what I'm going to do real quick is I'm just going to select the geometry that we just created. Go down and temporarily hide it so that I have this workspace still so I can see. And then what I'm going to do, like we've done before, place a point on one of the reference lines, set the work plane to that reference point, and then I'm just going to go around. Actually, I'll just create a rectangle around it. Tight line, and I'm going to increase the scale so that the dimensions aren't too big. And then first I'm going to dimension each one and make it equidistant from the point to the other edge. And then I'm going to do a height parameter and a width parameter. So height parameter, it's okay, and then do a width parameter. It's okay. Going real quick, and so our mullion width, let's make that 2 inches, and then our mullion height is 1 foot. See how that goes. All right, so now we have control of the mullion dimensions. Create form, and then go in, create one more material parameter for the mullion. Oops. That's okay, okay. We can reset temporary. Yeah, it's fine. Alright, let's save this as Kistefos curtain wall. Save. Load into project. Let's finish the mask real quick and then re-edit. The reason I did that, sometimes when you load families in and you're in the conceptual mask editing environment, it gets all funky. Let's go back in, change this from a rectangle to a curtain panel. Interesting. Alright, so it's hanging out quite a bit. And from the precedent imagery, we want that to be, actually we want it to be kind of like a butt joint almost. Let's go back into the panel, edit family, and then let's go back a couple. So that's actually align and lock front part of this panel in. That 12 inches, and then what I'm going to do is right now the glass is protruding from the face out. I'm going to grab that top panel, drag it down so that it's protruding out, and yeah, we have a negative. And then if we change that offset thickness to 1 inch again, yep, now it protrudes down 1 inch instead of up. Another way you can do that really quick, instead of just dragging, you can grab that top surface and then down here just type in negative, and it'll flip that orientation. Alright, and of course we need to actually create that mullion again, create form, create the mullion glass type, or mullion material type, excuse me. Okay, alright, now let's save this, load it back into the project, overwrite the existing, and then this is where loading families in the conceptual massing environment get weird. And of course, I've been alright, just go into a different, it's like if you go into that family again and then go back to the project, go bring up that finish mass again. Finish mass. Oh, and now of course it's updated. Alright. Shaded. Alright, so now we have those glass. We can go in, edit the tab in, grab the panel, edit type, and go in and actually set glass and aluminum materials for the material, or for the different panels. Type in aluminum. That's okay. There we go. Okay. So we can do that, go back in and edit the mass. And once again, I'm going to isolate the mass itself, so it's a little easier to select and divide faces. So divide the surface, we're just adding. Alright, we got to change this maximum spacing in 6 feet, and then the vertical layout is a fixed number at 1. And then we just change this to the current panel, or curtain wall family. And then do the same thing for this end over here. Maximum spacing, 6 feet. Fixed number 1, actually, I think. Oh, no, it worked. Perfect. Thinking we might have to flip those, but nope. Alright. Now the corners are going to be a little bit funky. They're going to be a little bit thick. But for right now, that's okay. Reset. Cool. Alright. So now we have a little bit nicer of a model. Matches at least somewhat the conceptual diagrams that they made before. And so what we're going to do now is we're going to create the structure. So if we finish this mass, What we're going to do is we're actually going to do what we did for this sidewall in creating a new mass. And we're going to manipulate the profiles to offset and then use that new mass as a basis for our structural system. So for the Kistefos Museum, they have these structural diagrams. Now, we won't get as complicated in the middle as they have. I'm going to keep it relatively simple just because it'd be somewhat difficult to isolate the different sections for different structural spans. But I know that you can visibly see the diagonal bracing from this angle, and that is one linear element going along the face of the mass, and so we'll use that as a baseline for our structure. All right, so go in and select the mass, make sure it's selected, and then what we're just going to do is we're going to copy that over. And be sure to remember how far you're copying it over. Actually, what I'll do, I'm going to go to a top view, copy, and I'm just going to move it over. Let's just do an equal 100 feet. The reason why I'm telling you to remember how far you copied it over is because when we finish creating our structure on this side, we're going to move it back over that same distance so that we make sure that it's in line with the existing elements. And so what we can do, go back, edit in place. Give it a minute. All right, cool. And what we're going to do is delete all of the divided surfaces that we created before, because we don't need them. And before we start creating this, I'm actually going to go in and synchronize my model, save it just in case it crashes. Especially for those of you who have smaller RAMs and less powerful graphics cards, make sure that you're syncing and saving as often as possible so that you don't lose any work. I'm going to turn off the levels again. I don't know why it created no 3D view, but whatever. All right. So what we're going to do is we're going to create the structure around this, and what we have to do from our precedent images, our structure is inset from the face of the glass a good at least a foot. So that's what we're going to do. We have to take our conceptual mass, offset the faces in at least a foot, so that when we look at our model, our structure isn't going through the face of the glass. So we're going to do the same thing that we did before. We're going to edit in place, and then we're going to go in and edit the profiles of each control curve. And we'll just offset 1 foot in, make sure our copy isn't selected. And then to do all of the faces, you can just tab in once, and it'll select all of the boundary line. And then just do that for the remainder of the profiles. Cool. All right. So now that we have our base mass for our structure, we'll go in and divide each surface. And I'm pretty sure you can do multiple at one time, so let's try that. Remember to select multiple elements at one time. Hold Control. It'll populate the little plus sign next to the mouse, and that way you can know. Keep grabbing that edge instead of the surface. One more. Alright, divide surface, and then want to change this number down here to 1, and then what we'll do to get the triangular angled diagonal bracing is go down, and what I found works best for this specific setup is the triangle step bent. Really nice pattern, and it matches the one that we're using right now. Let's go in. So it looks like the diagonal bracing is starting from the top right and angling down. So we'll mimic that on our model. So to do that, grab the divide surface and do an all grid rotation. Do a 180, maybe a 90, sorry. Let's try this one. Oh, all right. So I was looking at rotation because that's what was working for the previous. But down at the bottom, pattern application, you just do a component mirror. There we go. We got it. So actually, for this side, we want it the same. For this, we want it mirrored. Perfect. All right. So now we have our base grid. One thing to remember, we have 18 structural segments along the length of the building. And so right now we only have 12, so we need to change that to 18. Grab the bottom one. Okay, and then one other thing we gotta do is grab the face of each side and move it in 1 foot. And the reason we don't want that one face, we don't want the face of the perimeter beams to be protruding from the face of the building. So we want to have it inset a little bit. So we'll grab the other face and move it in 1 foot. Alright. It should be good. Again, they don't align perfectly because it's measuring from the center. But that's okay. Now, one way to fix this, fix the orientation of it, is over, excuse me, over in, if you click the divided surface, the belt measurement, so that's where it is measuring from to equally divide the distance between these fixed numbers. And it's the same value that we've been using. So 0 is probably at the base, 1 is at the top, and 0.5 is in the exact middle. And that uses those numbers to equally divide the differing divisions as it moves across this complex surface. And so if we want to align these two edges, what we can do is go to our U grid that has the 18 divisions, and we can specify it being measured from either 0 or 1. So if we do 0, and then if we do 1, it either will be 0 or 1. There we go. So we're telling it to divide equally along this edge for both this divide surface and this divide surface. So that at least one edge, and of course it's not going to be the same on the other side, on the other edge, but it'll get pretty close. So let's do the same thing over here. 0, and then let's do 1 for this. Oop. Make sure that you're doing the belt measurement for the 18 grid, not the 1, because that won't change anything. Alright, so those have aligned. Now, of course, these don't align because right now it's aligning, or it's dividing equally along this edge, not this edge. This is just a remainder on the other side, so they don't align perfectly. But it does give you a little bit more control, at least on two edges. I think if you try reversing this and doing 1, it would probably be, yeah, it'd be worse. Let's just do 0. Actually, you know what? I'm going to flip this because this is the side with glass, and so that's where you'll actually have the most visible alignment. Get those to align. And then let's flip this. Oh, not bad. So you just have some weird remainder down here. Let's try and flip it, just see what happens. I think it's pretty close. All right. Those are pretty close. Much closer than they were. So now that we have the divisions and the grids all aligning, what we got to do is create a new family to create the structure from. So if we finish the mass, do another new family, curtain panel pattern based. Alright, so what we got to do is we got to select this grid and change it from rectangle down all the way to the triangle step bent. And then we are essentially going to create these structural members. Now, if we go to this view, we can see that the diagonal beams are circular, and then our horizontal and vertical are I-beams or wide flange beams. So we'll try and mimic that. Now we're not going to create, you could, if you really wanted to, create a wide flange beam, and maybe, depending on how much more we'll do, maybe we'll go into how to assign a custom profile into this environment. But for right now, we'll just create a rectilinear scale. And I went in and tested this before I started recording to make sure that the which segment essentially was which. And so 1 to 4, the reference line between 1 and 4 is the the diagonal bracing portion of the segment, or the round portion, and then 1 to 3 and 3 to 4 is the wireframe scheme. Sorry. All right, so we're gonna have to create a reference point on each reference line, and then we'll go in and set, and then create the profiles. Now we want to be able to control the radius of the beam. So we'll go in, create a parameter, radius, sure it's type, it's okay. Go ahead and make that 6 inches. And then once again, I'm going to change the scale to a larger one so that the radius or the dimensions are a little bit smaller. Do the same thing for the others. So let's set reference point, create a rectangle, and do the same thing that we've been doing before. Equidistant, equidistant, and then overall width, overall height. So this is height parameter, this is our width parameter. And then let's do our height at 1 foot and our width at 8 inches, just to give it a little bit of rectangle. And then do the same thing for these guys. So set reference plane for the point, create a rectangle, add our divisions, or dimensions, excuse me. And since we've already created the width and the height parameters, we can just go in and set those from the table. One more. So the reason why we have to create 4 is because technically each length between the 2 reference points is its own individual point. So we can't, well, we could potentially just use one profile for the 1, 2, 3, and 4, but it may cause issues. So we're just gonna create each one. So remember, set, so reference point, angle, equidistant, oops, equidistant with height. Alright, and then what we're going to do is we're going to individually select each reference plane. So tab in, make sure you grab just the one, and then the profile, create form, same thing, grab the profile, create form, create form. Alright. Let's make this a little bit more elegant. Let's change the beam radius from 6 inches to 4 inches. Ooh, that's funky. I'm gonna try something real quick. Alright, so what I just did, so it was essentially only changing the radius for the center of the extrusion. And so what I did was just go in, select one of the edges on the end, and just do an edit profile, and then select one of the radius, and just grab the dimension, set the dimension to the beam radius parameter, hit enter, do it for the same on this side, and then when you change the beam radius, it changes all three profiles and changes the entire radius of the beam consistently. Okay, so let's save this one more time. Kistefos, Kistefos structure. Load this back into the project. And then go in, edit family, edit the mass, and then change this from the bent to the new structure family. It's going to take a little bit. Check that out. Looking good. Our horizontal is the radius, and our vertical is the rectangle. Now we're not getting a cross member. I wonder if that is because, so if we go in and change this to 2, give it a second. That's why. So what we are going to do is we're going to go in and add, we're going to remove this segment here, this segment here, and create one that's going across. Yeah. Alright, so let's undo that. Let's go back in. Let's actually, finish the mass. Sync if you haven't in a while. And then edit family. Alright, so what I'm finding is that it's only showing basically this rectilinear element and this horizontal, or this curved round element. And it's cutting off these two. So what I'm going to do is I'm going to delete this. And I'm going to create a reference line between these 2 points. Make sure to select that line that you just created. So I'll explain it a little bit further. So I'm going to select both of the reference points, and I'm going to do a spline through points like we have done in the past. And then with the line selected, I'm going to check this and make it a reference line. And then do the same exact thing by creating a profile, a rectilinear profile. Oops. Have to set, remember, to that reference point, and do a rectilinear around there. There we go. And then do the same thing we did. Past, distance, width, height. Use that reference line. Create form. Perfect. Alright, so we'll save this once more and then load it back into the project. Alright, that seemed to have worked. Alright, let's see if it works for the remainder of the portions. It might have to get inversed on this side. Let's see. Oh, we gotta go in, edit in place the mass, then change these to the structure. Alright, that one worked. Let's do the bottom. This one I don't know. Since we've mirrored the pattern. Oh, it worked. Perfect. I wasn't sure if we had, because we had mirrored the pattern, that it was going to populate this side, and we would have had to create a new element that flipped it, but looks like it worked. Perfect. All right. So, it looks pretty good, albeit, yeah, it looks pretty good. Let me go in and change some of the elements just to make sure they are editable. So that should increase in size. Oh, you know what I forgot to do? Forgot to assign a material. Alright, so that's what we'll do once this finishes thinking. Alright, that worked. Cancel. Alright, so let's go in, edit the family real quick, and then just grab all of the forms, create a material parameter, load this back into the project. Oh my goodness. It's taking forever. There we go. All right. So now we have our structure. Now we're going to place it back into our existing model. So we're going to go to our top view, move it back over that 100 feet or whatever distance you moved it over. Just send it in there. It's offset. Alright, so it's still intersecting with the mullions. Now we could do two things. We could either go in and reduce this I'm only in height. Or what we could essentially do is go back in, go into the conceptual mass and offset those floors back in there. Feel free to fast forward through the next part of this, but I'm just going to do it so that it is correct. It looks like I'm going to have to offset it in at least 6 inches, so I'll do 8. Isolate the profile. Alright, so it's taking a long time to update, so I'm going to do this real quickly. You can do it on your own, or you can just turn in what, if it's intersecting, you can turn that in. I'll be right back after I finish updating. Alright, so after offsetting the one face in 8 inches, I have a result that is pretty nice. Now we don't have any conflicts between the structure and the curtain wall, except for when it twists, which, yikes. Which is okay for right now. So what I want you to turn in, one thing that we got to do, grab your structure, go down to work set, change it to building structure. And then what I want you to do for your assignment is just do basically 3 axonometric views, one with just the site on. Actually, let's do this. Let's have the site on for the whole, the whole time. Then do one with just the structure. So we'll turn these off, hide them. Just have structure on, press OK. Submit one view of just the structure, one view of just the core, which actually this is the exterior skin. Oops. Yeah. It's also the skin. So the building core, which at the moment is not much, just the floors, and then one of the skin itself. And then show one with everything turned on. Okay, I'll have that in the assignment. As always, let me know if you have any questions, any issues. I am more than happy to hop on a WebEx call or anything like that to talk through any issues that you may be having. Most people seem to be able to get their questions answered over email. And be sure to, especially if it's a complex issue that you're having with your file, be sure to send your file, not just a screenshot, because a lot of times I can't diagnose exactly what is wrong with the file just from a screenshot. I have to actually go into the Revit project and explore a little bit. So that's it for today. That's it for this week. Let me know if you have any issues. I hope you guys are doing well. Thanks.